So it's been requested I do a video on dynamics and kinematics, mechanics for Nat 5 physics. So yeah, to do a full course. It will take a while because there's actually quite a lot of stuff, but I'll starting off with this lecture. So dynamics consists of mechanics. Dynamics is about the movements of objects. Okay, mechanics deals with the movement of objects and how objects sort of move and forces and stuff that act on them. And then kinematics so this is part of classical mechanics. It's part of classical mechanics. Which is what Isaac Newton came up with, okay? It's what he discovered, the laws of motion, 3 laws of motion and gravity, and everything that's built off that. So this idea, kinematics, describes the motion of points of bodies, objects, or groups of bodies. When you have a group of bodies, a system of bodies, but not looking at the forces acting on them. Okay, so kinematics might look at the motion of all the planets in the solar system, but it doesn't look at the forces acting on them. It just studies their actual motion and paths, the shapes of their orbits. So kinematics equals the geometry of motion. Okay? So you're looking at the actual geometry of moving objects, but starting with you state the initial conditions. So when you have the movement of a planet or a football, you state the initial conditions such as the starting velocity, positions, accelerations. Okay. Such as the starting velocity, acceleration, and position. Okay. So when dealing with the average speed, okay, speed equals distance divided by time. Okay. By the way, I'm not quite sure what the person wants help with, or any of you do, so I'm just going to go through everything. Some of it might seem more boring or less relevant, but it's all actually important and interesting when you get involved in it. So distance is speed to time. Okay. Sorry, speed is distance divided by time. Okay. So you have, for example, if a cyclist takes 5 minutes to travel 1600 meters, which is about a mile, to travel 16 Okay, so calculate what is average. What is the average speed? The average speed also equals the distance divided by time, I should say. Okay, because the speed equals meters per second. Okay, or meters per minute or meters per hour, but normally you use units of meters per second. Or you could use miles per hour. And cars usually measure miles per hour because they're going fast, but walking speed might be miles per hour or meters per second. So what is the average speed? Okay, so the solution, time equals 5 minutes, okay? Which equals 5 times 60, that's seconds because there's 60 seconds in a minute. So the total number of seconds is 5 times 60. 5 minutes times 60 seconds per minute. So the average speed equals distance divided by time, which equals 1600 meters divided by 5 times 60, okay? Which is equal to 5.3 meters per second because you bring the S up on top. Okay? Example 2. So again, the average speed, distance divided by time. So if a car travels 15 kilometers at an average speed of 25 meters per second, okay? So calculate the time taken to travel 15 kilometers, okay? So 15 kilometers equals 15 times 10 to 3 meters, okay? Which equals 15,000 meters, okay? So calculate time taken to travel 15 kilometers, okay? So when the average speed equals distance divided by time, if you cross multiply these two, if you multiply both sides by t, okay? So you get t times average speed equals, those cancel, equals distance, and then divide both sides by average speed, okay? So divided by speed equals distance divided by average speed, okay? So because this is a product, time times average speed divided by average speed, those cancel. You end up with time equals distance divided by average speed, okay? So you can fill the bits in. The distance is 15,000 meters, okay? Divided by the average speed, 25 meters per second. Which comes out at, when you put that through your calculator, that the meters cancel, m and m cancel to leave seconds. seconds to the minus 1 below. So that comes out as 600. The seconds goes up on top, so you end up with seconds. Okay? 600. So 15,000 divided by 25, if you punch it through the calculator, equals 600. Okay? See that? So yeah, the average, the time taken to travel 15 kilometers is 600 seconds, which is 10 minutes. Okay, over 300 seconds in 5 minutes. Okay? So, right, if you have any questions, ask me. Right, those are two examples. You could do another one where we worked out the average speed, we worked at the time. You could work out distance, but I won't do one at the moment. So, scalars and vectors. Okay? So a scalar is basically a quantity which has no direction. It has a size, okay? So for example, 10 meters or 10 millimeters or 20 seconds, okay? Or 30 kilograms or 10 grams. These are scalar because they're quantities, they have a size or magnitude, but they have no direction. So distance is a scalar. A vector has distance, direction as well, size and direction. So for example, 10 meters east or 5 meters per second, okay? Or 10 meters per second squared. So that's velocity or speed, and that's acceleration. Because the velocity is number of meters you cover per second. So this rolls has a velocity of say 3 centimeters per second, okay? But if I speed it up like that, it's for every second. It's actually for every second of time. It's actually moving it, say 3 centimeters per second. Okay, so because the seconds are a product, because they're multiplied by each other. For every second, it has a velocity of. What it means is it starts off at 3 centimeters per second, but a second later, its velocity is it's increased by 3 centimeters per second, so it's actually speeding up. It's actually getting faster and faster. Okay, because it's basically a square of it. It starts off 3 centimeters per second, but a second later it's changed by 3 centimeters per second again, so it's become quicker. Okay, that's what acceleration is, actually speeding up. I'm not sure if I explained that very well. So yeah, so displacement velocity and acceleration and force, okay, are vectors. Force is basically mass and times acceleration. It's the product of something as a mass and you accelerate it and you get hit. As a force, it hits something with a force and pushes it. So if I push it into this one, like that. Da, 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 da. So this is hitting that with an acceleration. The difference with acceleration and velocities, as time goes by, it stays the same. If something moves, a car or a ball moves at a constant speed. Speed doesn't change at all. Every second of time, every fraction of a second, and every minute and every hour, the speed, or every 3 seconds, every 4 seconds, the speed stays the same. But with acceleration, the speed is continuously, the velocity, number of meters per second is changing. It gets quicker and quicker, or deaccelerating and slowing down. So that's why it's described as it's per second. It's actually speeding up. For every second it goes meters per second faster. So the force is the mass, the time product of the mass and acceleration. You get an impact. Okay, so if you simply roll it, it does. It hits it gently, but if you're actually accelerating, like the force becomes much more powerful, like that, rather than just going. It's not very. Let go. Okay, becomes more powerful. So yeah, when you're dealing with vectors, you must always draw a vector diagram. Okay, so you have north, east, south, west. Okay, origin. So okay, so you always draw a vector diagram when you do this. This is more of a map coordinate, but vector diagrams are similar. You would have well, you do it like this. You have, say, that'd be gravity downwards. Okay, that would be the normal going upwards. Okay. And then that would be flat, so you'd have gravity going, normal going up, and you might have a force going that way, okay? So, anyway, so these are the angles. So this is described as, so that's basically east, and this is described as 10 degrees north of east. That's described as, OB is described as 20 degrees east to south. So that's 10 degrees north of east, 20 degrees east to south. Okay, so that's equals 20 degrees east of south. OC equals 75 degrees west of, that's 75 degrees west to south, okay? And OD equals 50 degrees west to north, okay? Hope you follow that. So that's 50 degrees west to north. That's 75 degrees west to south. That's 10 degrees north of east. And that's 20 degrees south of, sorry, east to south, okay? West of north, okay? So that's, this is, so yeah, so to make this clear, this is the bearing 0, 0, 0 up here, okay? Yeah? Maybe up So yeah, this has got the bearing 0, 0, 0. This is 90. So yeah, okay, so north has the bearing 0, 0, 0. That's 90 degrees going around 180, 270, 360, okay? So when you have vector A0, which is 10 degrees north of east, that is 90 minus 10 is bearing of 80. Bearings are always 3 coordinates. When you have vector OB, which is 20 degrees north of south, sorry, 20 degrees east of south, 180 minus 20 is 160, so the bearing is 160. When you have OC, that is 75 degrees west of south, that is 180 plus 75, which is the bearing of 255. And OD is 50 degrees. So yeah, OD has a bearing of 360 minus 50, which is 310, and is 50 west, 30 degrees west north, okay? So, and when you're, so this is map coordinates, this is forces. Gravity pulls down, so when you have a person standing on the ground or a car, although the gravity is pulling into the ground actually pushes back with what you call normal, or it pushes back against the car with what you call normal force. So we're standing in the ground, our table stands in the ground, but the ground is pushing upwards as well. So yeah, the